Let us solve this Latin square problem. Okay, so in general, what do you mean by Latin square? So it is an n different symbols, each occurring exactly only once in each row and exactly once in each column. So see this example. Present your conclusions after doing analysis of variance to the following results of Latin square design experiment conducted in respective 5 fertilizers which are used on plots of different fertility. So here we have the category 5 different fertilizers and it is used on the plots of different fertility. So before solving any one-way ANOVA, two-way ANOVA, whatever it is, I said if the values are very big, change it to a smaller number and it is useful for your calculation. So you can keep as it is and you can, when you square it, and if the sum also becomes too huge, so most of the values are scattered around 10, 11, 12. It's like you can take 10 or 11 or 12 or even 13. Any value you take, so that the number of entries should be very less. For example, 16 I will write here. It's 16 minus 13 if I take. So this will become 3. Okay. 10 minus 13. So this will become minus 3. 11 minus 13. This will become 2. 9 minus 13 minus 4. Again here 9 minus 13 minus 4. Similarly, we can write for others. 10 minus 13 minus 3. 9 minus 13, same, minus 4. 14 minus 13, 1. Let me write for all columns and rows. So now instead of these bigger values, it has changed to smaller value. So 16 minus 13, you will have minus 3 is the first value. And second value, again minus 3. 10 minus 13. And then 11 minus 13 is 2. 9 minus 13 is minus 4. This is for the first row I am talking about. And then again this is minus 4. Normally for all ANOVA, what we will do? We will take the total. So when you take the total, this is minus 10 because minus 4, minus 8. And then these are all the negative values. Minus 8, minus 6, plus 2. So while adding all these things, oh, this is equal to, not minus. So 16 minus 3 and plus 3, these two will get cancelled. And then 11 minus 13 is minus 2. I missed the sign. So minus 4, minus 2. It is minus 10 is the total. Similarly, second row, what are the values? Minus 3, minus 4, 1, minus 1, minus 2. 1 and minus 1 will get cancelled. Minus 3, minus 4 is minus 7. And then minus 2, total is minus 9. Same way, add these values only. 2, minus 5, minus 5, minus 3, 5. Plus 5 and minus 5 will get cancelled. And minus 3, 2, so minus 1, minus 5, so it is minus 6. Similarly, if you add this, you will get minus 9, minus 10. Same way, you are going to add column wise also. So if you add column wise, let me rewrite this. 3 minus 3, this row I am writing. Then this row we have 2, this minus 1 and 0. So now if we add all these things, what we will get? 1. Because this is minus 4 plus 5. So 1. Same way, when you add this, you will get minus 21. At this column minus 9, minus 14, minus 1. Remember, when we add both, you should get the grand total, which is minus 44. Add all these things, you will get minus 44. Similarly, add all these values, you will get minus 44. From this, we will find the correction factor. Always the correction factor formula is T square by n, which is, it is going to be positive because we are squaring it. Minus 44 square by, how many values are there? 25, because it's a 5 cross 5 matrix. If you see 5 rows and 5 columns, so automatically you will get 25, and this answer is supposed to be 77.44. So same way you are going to find SSC, SSR and all those things. So it is the same. Since we are taking SSC, So we are writing column wise values total. So what is the column wise total that we are having? 1. So I have written 1 square by. So here minus 21 square, minus 9 square, minus 14 square. So anyhow this will become plus 14 only. And then minus 1 square. I have written all these things. Don't write the total. Minus correction factor. Correction factor is this value. So this is SSC. When you calculate, again add everything and then finally subtract. Same way SSR means row total is there, no? Minus 10 square by 5, minus 9 square by 5, minus 6 square by 5, minus 9 square by 5 and minus 10 square by 5. So why we are dividing it by 5? If you take any row, we have 1, let me use 1, 2, 3, 4, 5. 5 values are there in the row. Same way, 5 values are there in the column also. 1, 2, 3, 4, 5. Since it's a 5 cross 5 matrix, in Latin square there is no tension of writing a round number. So we have written SSR also. All these are row totals that we have seen minus a correction factor, and this will give you 2.16. So remember SSC and SSR we got it in two-way ANOVA also. Now you have SST, total sum of squares, and also we have to find within the letters also. And now if you see SST, it's going to be summation of all values in the tabular column minus correction factor. I told you, right, since we reduce this, it's easier. 3 square 9, again this 3 square is 9, then 2 square is 4, 4 square is 16, minus 4 square is again 16. So it is easy for us to write this 9 plus 9 plus 4 plus 16 plus 16. This is your first row. And second row, 3 square 9, 16, we are just squaring it. So 9, 16, 1, 1, 4. So I will write the same thing. Similarly, you have to write for the next two rows. So 9 plus 16 plus 1 plus 1 plus 4 plus 4. And what is the third row? Third row has so minus 1 again. And then here 2 square 4, 25, 25, 9, 25. Similarly, I'm going to write for all the rows. And I have written, so first 5 values this color, and the next 5 values in green, next 5 values in red, so that you won't miss. And these 2 became 0 because 13 minus 13 the whole square, so this is 0, and again this is 0. So it's all giving you easier value to calculate, and this is supposed to be 196.56. So you have calculated SST also. So one extra thing is SSL we have to find in Latin square. So now before squaring it, because we will find summation of A and then we will square it. Summation of A means letter A, what are the values it contains, that I will write, because the bigger one we simplified. So what is the first letter A value here? I will use some blue color. Okay, A has 3. Here A has 3. Only one row or one column you can see. And second A is 1. 3 plus 1. Third A is here. Plus 5. Fourth A is here. 0. Fifth row A is minus 2. So what I will write? Here 3 plus 1 plus 5 plus 0 minus 2. This is 7. Similarly, we are going to find for B. Okay. So for B, it's like you can check row wise or column wise. It's your wish. So for B, I'll put a star here. So B is 10 minus 13 minus 3 is here. Second row, minus 1. Third row, here it is 2. Fourth row, 0. Fifth row, 1. So I'm going to write it in the same order. Minus 3, minus 1, 2, 0, 1, which is minus 1. Similarly, you just write this in one separate paper and then verify with me. Minus 2, minus 4, minus 3, minus 1, 0 for the letter C. And for the letter D, minus 4, minus 2, minus 5, minus 1, minus 3, which is minus 15. And finally for the letter E, minus 4. These are the values that we have. So after writing the letter, the formula for SSL is summation of A the whole square by, again letter A how many times came? 5 times, plus summation of B the whole square by 5, plus summation of C the whole square by 5, plus summation of D the whole square by 5, plus summation of E the whole square by 5 minus correction factor. Please keep this in mind. These squares or this sum is easy for us only because we have reduced the value from the given question. So you can solve it as it is, but it will be too big and you may do some mistakes. So 122.56 is the answer. So SSL also we have got. SSC normally what we will do? SST minus SSR plus SSC plus SSL. You can write in any order because summation. So what we got is 196.56 minus your R is 2.16 plus, I'm writing all the values, and this calculation value is nothing but 5.28. Just check by yourself. Now you got all the values, your final tabular column. It's ready now. So first is source of variation. We will write between column and between row, between the letters, and then residual. These are the 4 things in first column. Sum of squares means total sum of squares in column. We got 66.56. For row 2.16. Between the letters just now we have calculated, and SSE here it is 5.28. So the residual SSE. Now we have to write degrees of freedom. So now number of column minus 1 will become here. So how many columns we have? Same, 5 columns, 5 rows. So row minus 1 is 4. Latin square, these two will be same. So V is nothing but your number of letters minus 1 here. So column minus 1, row minus 1, letters minus 1. 5 letters we have, so 4. And here this final degree of freedom, what we will write it as 4 into 3. Why 4 into 3, which is 12? This is nothing but n minus 1 into n minus 2. Normally we used to multiply the above thing, right? So total n is, it's a 5 cross 5 matrix, correct? So n is equal to 5. So 5 minus 1 is 4 and 5 minus 2 is 3. So this is 12 degrees of freedom. Now mean sum of squares, what we will write? Always SSC by this. So MSC is equal to SSC by 4. So which is nothing but 16.64. Similarly 2.16 by 4. MSR is 2.16 by 4, which is nothing but 0.54. Similarly MSL is SSL by 4, which is nothing but 30.64. And MSE is again 5.28 divided by 12, which is nothing but 0.44. So now you have to calculate the F ratio. So the first F ratio is 16.64 divided by 0.44. We are going to divide with this value. So your first F ratio is 37.8. Second F ratio is 0.54 divided by 0.44, which is 1.2. And third F ratio is 30.4 divided by 0.44, that is 69.63. Now you have to compare this with the table F value and conclude the result. Since all three has degrees of freedom 4, 12. See, the first one is also 4. Second one also 4. Third one is also 4. So 4, 12 combo. No need to see the tabular column again and again. It's 3.26. Your first value 37.6 is greater than this. So we will reject the hypothesis. Your second value is less than this hypothesis, the table value. So we will accept, and the final value, which is again greater than 3.26, we will reject the hypothesis. So always if the calculated value is greater than the table value means we will reject or we will accept the hypothesis. Thank you.